So ideal oscillator, see, it is a noiseless magic box or whatever amplifier you will have inside that, and definitely you will have an RLC tank circuit. And assume that there is only thermal noise in our amplifier. So the thermal noise RMS value of current is given by this equation, IN square equal to 4 kTg delta into F. And here IN square bar indicates I'm going to measure the RMS value of the noise current. Okay, I'm going to measure the RMS value of noise current. And G is the tank resistance, conductance of the tank. It is, G is equal to 1 by R. So the current noise becomes voltage when you're going to multiply by the impedance of the tank. So if you want to convert the current into voltage, IN square, if you want to uh, write in terms of VN square, if you multiply IN square by the impedance, it will become equal to VN square. So that can be done. That is what either you can represent that as a Norton form, or you can represent a Thevenin's form, either by using the equation for IN square, or you can use the equation for VN square. So see, the circuit will oscillate with a constant amplitude. So this magic box must provide a negative resistance to cancel the resistance of the tank. See, actually, ideally, only when L and C are only present, it will produce oscillations. But unwantedly, we are having this R, which is going to dissipate the power. So I want to cancel out this R. So only way of cancelling out this R is this noise box has to have a resistance minus R. Only then this R and minus R will cancel and the net resistance becomes zero. So LC will be there, it will perfectly oscillate at a constant amplitude and phase. So that is why they say oscillators can oscillate, some oscillators they possess negative resistance. So all devices having negative resistance are oscillators, but all oscillators need not have negative resistance. So these two statements have to be very clearly understood. So if you have an oscillator, there is no condition that it has to have negative resistance. But if a device is going to possess negative resistance, then it will definitely oscillate. And I can say this negative resistance, you cannot physically see resistance with value minus 1 ohm or minus 2K. What is negative resistance is, if your voltage is increasing, if actually by Ohm's law, V is proportional to I. So as your voltage is increasing, my current should increase ideally. That is the ideal amplifier. This should be the ideal case. But in negative resistance, as the voltage is increasing, the current will start decreasing. So this decrease in current is denoted by negative resistance. So this region of the graph is an unstable region. And if you bias this region in your device, it will start oscillating. So that is why indirectly we put a minus R to bring the negative resistance concept inside your oscillator.